Welcome to the Explainer. Today we are jumping straight into Chapter 9 of our source material to absolutely demystify Python lists. We're going to take what might seem like pretty dry programming syntax on the surface and transform it into the most powerful dynamic coding tool in your daily arsenal.
I absolutely love this Bill Gates quote because it perfectly captures exactly why we need powerful, efficient tools like lists, right? We don't want to write heavy, clunky, repetitive code. We want to write lighter, smarter code that gets the job done elegantly, and lists are going to help us do exactly that.
All right, so here's our roadmap. We are going to treat the Python list just like a Swiss Army knife today. We'll start with the basic blueprint and then move all the way through operations, slicing, and those tricky advanced techniques like nested data and function arguments. Let's get to it.
First up, let's meet the Python list and check out the blueprint. Now, the absolute key word to remember here is mutable. It is a total game changer. Unlike some other rigid data types in programming, lists are mutable, which just means the contents of the list can be changed after it's been created. So you can dynamically overwrite an item, like swapping the color red for black in a list of colors without having to build a completely new list from scratch.
And this brilliantly illustrates the difference between something like strings and lists. Strings are super rigid. They consist only of characters and they cannot be changed in place. But lists? They are incredibly flexible. Not only are they mutable, but they can group together completely mixed data types. You can literally have an integer, a decimal float, a text string, and even another list all living right next to each other inside the exact same set of square brackets. No problem.
Moving on to basic tinkering. Let's look at operations, slicing, and traversal. Python makes manipulating list contents so intuitive with just a few core operations. You can actually staple lists together using the plus symbol. That's concatenation. So if you have a list of odd numbers and a list of even numbers, boom, adding them together joins them end to end. You can also multiply them with the asterisk to repeat elements. And maybe my favorite, you can instantly check if an item exists inside your list using the in or not in operators. It's just so simple. But what if you only want a specific chunk of your list? Well, to carve up our data, we use slicing. The anatomy of a slice relies on this really clever start, stop, and step structure. You define your start index, which is inclusive, then your stop index, which is exclusive, and finally the step size, which is your interval. If you navigate that structure, you can extract exactly what you need. Or, here's a fun trick, if you omit the start and stop entirely and just use a -1 for the step size, you reverse the whole list in one swift move. Okay, next up, let's look at our power attachments, adding, removing, and organizing data. We can selectively add data to our lists without rebuilding the whole shebang. You just use append to snap a single element right onto the very end. But if you have an entire second list you want to merge, extend unpacks those items and adds them all to the end. Or if you need real surgical precision, insert lets you drop a new element exactly at the index position you specify. Of course, a good toolbox also has to help you dismantle things, right? When you're removing data, you've got to choose your tool wisely. The remove method deletes the first occurrence of a specific value that you pass it. But pop? Pop acts more like a targeted strike using the index number. You tell pop exactly which position to clear out, and it actually hands that removed element right back to you in case you need it somewhere else in your code. And organizing is an absolute breeze. With a single line of code, you can use sort to arrange your elements alphabetically or numerically. You can use reverse to completely flip the order, or count to instantly tally up how many times a specific value shows up. The best part? These are all done in place, meaning your original list is permanently restructured. You don't have to clutter things up by creating a brand new variable. Let's step it up a notch. Lists inside other lists, also known as nested data. So, sometimes one toolbox just isn't enough. The solution? You put a toolbox inside a toolbox. Chapter 9 refers to this as a nested list. Accessing your data here looks just a little bit different, but it's super logical. You just use two sets of square brackets. The first index targets the nested list itself, essentially opening up that inner toolbox. Then, the second index grabs the specific item sitting inside of it. All right, please pay close attention here because we are entering a major danger zone, the copying trap. Let's say you have a list and you want to make a copy. If you simply use an equal sign, saying list 2 equals list 1, you are not actually making a copy. You are creating an alias. Both variables are not pointing to the exact same object in the computer's memory, which means if you change one, you inadvertently change the other. To avoid this trap, you have to create a true clone. You do this by using the slicing method with empty brackets or the built-in copy function. That gives you a totally separate, distinct object that you can safely mess around with.
That memory concept leads us perfectly into our final section, passing lists as function arguments. Handled with care.
So let's see how this actually builds out. When you pass a list into a function, you're passing its memory reference. This means if your function loops through and tweaks the elements, let's say adding 5 to every single number, your original list back in the main program changes too. The only exception here is reassignment. If inside the function you assign a completely new list to that variable, it creates a local copy. It severs the link, so changes no longer affect the original list. Seriously, understanding this one distinction will literally save you hours of frustrating debugging.
The final part of Chapter 9 pulls all of this together by showing you how to build a fully interactive, menu-driven program where a user can append, insert, modify, and sort data endlessly. It's incredibly cool. So, I want to leave you with this final thought. What data in your own life would you organize using an interactive Python list? Think about how you could use these operations, your brand new programming toolbox, to track, sort, and manage the information that actually matters to you. Thanks so much for joining me on The Explainer.